My name is Marcin. I work in iOS platform team here in Bloomberg. In this presentation, we called Beyond Unit Tests, together with my colleague Kass, who will jump on the stage in a few minutes. We'd like to show you how we use and benefit from integration tests. Very small agenda for this evening, so for this talk. First, we'll kind of have a brief overview of unit tests and integration tests, and maybe try to find some differences between those two types of tests. And shortly after, we move to the kind of main bit of this presentation. So we have two examples. In the first example, we'll test an application which is using WebSocket. In a second example, Kass will present how we test command line tools. So, unit tests versus integration tests. What is the difference? We should use unit tests, we should use integration tests. Well, to be very honest with you, I think sometimes the differences kind of might be a bit blurry. So instead of answering this question now, I'll try to a little bit work around it. So let's talk about unit tests. I'm sure we all use them. So unit tests, as we know, they're focused on individual units of code, like classes, maybe even smaller, like methods, functions. Because we want to run those tests in isolation, we usually mock all the dependencies using mocks, stubs, and things like this. And also, in unit tests, we don't use I/O, networking. We don't use file system databases and things like this to make them fast and robust. Additionally, because they are so nicely isolated, we can easily parallelize them to make them even faster. When we look at this common testing pyramid we see almost all the time, our unit tests are straight in the bottom. And at the top of this pyramid, we have UI tests, also sometimes integration tests, which, again, they're completely different. They test the application really from the top to bottom. In the midsection, we have exactly what we call integration tests. And again, I know this term might be not really precise, and maybe some people have some system tests, some other kinds of things, but we just call them integration tests. And one might ask, OK, but what is the scope of integration tests, right? So for unit tests, we have the scope very, very nicely defined. For UI tests as well. And here, it looks like we have lots of freedom. And that's actually kind of a benefit of integration tests. So we can pick up the scope that really kind of gives us most value. And by value, I mean most confidence. Sometimes we might think, OK, it's worth testing multiple layers living in a kind of single application, and it's great. In other situations, we can also think about components which are running even on different devices. For example, some components work on our client, iOS client, some other components working on the server side, and again, we want to test them together to make sure they're all working as a whole. And again, integration tests are really facilitated. And here we're moving to our first example, simple iOS application, and here a small disclaimer. So this is not going to be like a real application we're working on, but just we created this application purely for this demo. However, all the techniques, kind of approach to testing is something we use and normally use in our normal project. So here are simple requirements for application. Yes, this application is like a very basic iOS messaging application. So here the requirements are that, well, when we connect to the server and we send a message, we expect this message to be quickly delivered to all connected clients, kind of like broadcasted, including us. The second requirement is that when we connect, we expect the server to push the messages, like the history of the messages, immediately to us. So we are kind of having the same context as other users. And the third requirement, to make this application a little bit more realistic, we want to run it on iOS 12 and iOS 13. This is like super ugly UI. I'm basically implemented for this. So in this yellow rectangle, we have kind of like all the messages we receive from the server. Then we have this white rectangle where we can just enter some text, and then this orange weight button, which allows us to send messages to other clients. But we're not going to talk about UI today, so we can forget about it. This is purely just to visualize the domain. And also, we have simple apps, so we have a very simple architecture. At the very bottom, we have a layer, actually library in this case, WebSocket, and as the name suggests, the layer basically deals with the WebSocket protocol. On top of it, as a delegate, we have a layer called networking, it's library again, and this layer implements our custom messaging protocol. Also, this layer kind of nicely abstracts the underlying transport. So, for example, if tomorrow we decide to completely abandon WebSocket and move maybe to raw socket connection, something else, we can do it, and the client code, like UI, in this case, will be completely unaware of this change, which is really a nice property to have. But there's one little problem, because we're targeting iOS 12. As far as I know, we cannot out of the box use anything that iOS provides us to implement WebSocket. So we need to find something else. And purely for this demo purpose, I just picked up a third-party library called Starscream, which is actually a really great library, very simple to use. Here's the kind of main interface that allows us to do the main things which we can normally do with WebSocket. So we can connect, disconnect, we can write something to the socket. And to receive and to receive some information from the socket, as well as kind of like get the state of the information about the state of the connection. Again, we just need to implement this simple delegate, and that's it. To establish the connection, just again, I think the author of this library did a very great job. Just 5 lines of code when we need to craft basically a simple URL request, point to our server, pass the request to the library, set the delegate, call connect, and it's really working. So, because, well, the interface of the library is really straightforward, I would say even very narrow. And also, I guess if we picked up another library, the interface would be actually very, very similar. We can easily mock it. So if we can mock it, well, we can just unit test our networking layer, right? So we imagine a situation we implement, and we can easily test our networking layer. We can also easily test all layer buffs. And we don't even need to connect to the network, right? Because, well, we can mock everything pretty much easily. Also, we know, because we're looking at the code, the WebSocket library is also tested. So it looks like the whole application is actually already tested, which is nice. Here is a very simple test we can write, like a unit test this time. So yeah, we spent like 10 minutes, and this is the first test, which is kind of funny, but anyway. So this test looks very basic, and actually it is basic. What we do here, we mock WebSocket. We pass it to our networking client, the default network client from our networking library. Then we call connect and verify that this connect intent was passed down to the underlying WebSocket library. And again, this test looks very silly, but it can, for example, help us to verify if our initial WebSocket upgrade request contains all the necessary data in the headers, for example, some authentication tokens and a token and things like this. In the same way, we can test this connection. So again, we create a mock, we pass it to a networking library, we call disconnect, and we verify that actually the library received the disconnect event. And last unit test I have for you today is a test that kind of confirms that we can receive information from the server. So what we do here, we simply like hard code some expected payload, because our messaging protocol basically uses JSON underneath. So we kind of like simulate situation when we received this JSON through the WebSocket. Then we propagate it up to our networking library. We expect the library, our network client, simply to pass this JSON, pick up the content of the message, and pass to its listeners. And again, this test is passing, so everything looks all right. And now this is a kind of like small survey, I guess. Imagine a situation we have more tests like this. Like literally we have all application covered, so we have code coverage 100%. We have all sanitizers, all the checks. We profile the application. We have code reviews, all the best practices we can have, and everything seems to be fine. We never connected to the server, but everything else seems to be okay. And now the question for you. Please raise your hand if you would like to ship this application. I know the UI is not perfect, but just ignore the UI. Let's focus on the functionality. So if you ship this application as it is now, please raise your hand. What? OK, I see no trust in my skills. Actually, I expected this a little bit. It would be probably a good idea to ship it at the current stage. But I have a bit more insights. So I know it's risky, but first, when I simply like implemented first the mocks, because, well, I didn't even generate them, I implemented myself, and also kind of analyzing this library and the behavior, I started thinking about a few things. So here we have the write method, right? And we had the callback. And this callback looks like so easy to implement. You just need to pass a closure. But actually, what is the callback? I mean, is it guaranteed that this callback is always called? Like always, every time when we write something. Or maybe it's called once. But if we send a very big message, maybe it's actually called multiple times. Also, I wasn't sure if it's guaranteed that this callback will be called always on the same thread. Or maybe it's actually not that deterministic. And finally, which is funny, I wasn't sure what is the kind of behavior of this callback. What does it actually mean when it's called? Does it mean that the message has been delivered to the server? or it's just the message has been passed down to the IPTCP stack locally. Also, there were some other things I wasn't sure about, really. For example, error. So there's this kind of very generic type, error type, and again, what should I do with this error? Probably the easy thing would be to get maybe something like localized description, then pass it up to the UI, and things should go fine. But again, localized description might contain very obscure information, so we probably don't want to show it to the users. And the one way of getting rid of those doubts would be just to connect to some kind of infrastructure we have in our organization, like maybe UIT environment, dev environment, maybe, I don't know, prod environment, then maybe put some breakpoints, test manual application, and see if it's working. But this doesn't really scale, because if we change something on the server side, then we maybe need to repeat those steps. If we change something on the client, exactly the same thing, we need to do it manually. So we would think, let's automate it. And that's where our first integration test comes. So here we have the test which looks exactly like our unit test with few small differences. So instead of mocking WebSocket, here we're now using the real implementation, like the real implementation using star scheme underneath, and we connect to the real server. So now when we run this test, once we receive basically the callback, the connect confirmation, then we know actually it worked, which is nice. The only difference here, also the second difference between this test and the unit test is this test is asynchronous, just we need to wait for the connection. And exactly the same way we can test this connection. So again, first we connect to the server, then we call connect, and then we simply expect this kind of confirmation that yes, we connected. And this is actually passing, it's all good, underneath it uses star scheme and everything is fine. But I was thinking, I want to be ready for the future, so when we might start supporting just iOS 13 plus, then maybe we'll drop the third-party library, we'll start using URL session, WebSocket task, so things will be easier and our bundle will be smaller. So I have the alternative implementation, I run this test, and surprisingly this test is failing. And there is a small detail about this test that it expects the disconnect event to be delivered exactly once. And for some reason, actually the URL task delivers the disconnect twice. And one might think, okay, I know that I'm disconnected and the second event is just like confirmation, so maybe it's fine. Maybe it's just kind of this innocent event that happened and we're okay. But I can easily imagine a situation when we actually respond to this event in a way like, for example, we try to reconnect to make sure the device is constantly connected. And then when we receive two events, we can try to connect twice, and then we might receive 4 events. And those things are growing exponentially, so really, really bad things can happen. But because we have those integration tests, actually it's not the end of the world. So what we would normally do is probably we could create a separated integration test, just the one exercising only URL session, so we have this expectation that this event is delivered twice. Then we would put a small workaround in our implementation just to kind of dedupe this event and move forward. And once the URL session is kind of fixed and we don't have this behavior anymore, we can simply remove the test, remove our workaround and forget about it. Here's another test we had in our unit test suite. This test is a bit kind of like bigger. So previously we had a test that verifies if we can receive the messages. This one is actually doing 2 things. It sends message and they expect the message to come through back. So here we created 2 clients. We connect 2 clients. One client is sending a message and the second client is expected to receive a message. As simple as this. And this test also failed for a very funny, very basic reason. I simply messed up the JSON format parsing. So again, it might be a typo, maybe I misread the documentation, maybe the server actually, there was some rollout overnight and something changed. So, it was kind of nice. I had this test because it caught this problem. And also now I can go back to my unit tests and kind of like adjust this payload. But there might be more problems generally. So, we're all working with mobile. And, as we know, mobile devices are constantly, reconnecting, switching networks. Bad things can happen. Also, maybe our infrastructure is temporarily unavailable, and still, when things get back to normal, we expect our application to basically gently recover. And how we can test it? I'm sure there are multiple ways to do it. One way I kind of know and used before is simply to set up a small proxy server locally on our host machine, then connect to this proxy server, maybe tweak some settings, and you see, just verify if everything is fine. But it seemed kind of okay, but on the other hand, we need to kind of put some documentation for other developers, for other people, like how to use it, know how, share these things. Maybe we need to kind of like fix the version of the tool to make sure everyone has kind of the same software running and things like this, which is maybe okay, maybe not. But I overlooked also other problems. So before, when we like running those integration tests, we were connecting to kind of this shared resource, some servers running in our organization. And those servers can be basically, again, used by other developers, maybe some QA people, maybe some beta testers. And every time when we do something there, we kind of like affecting this environment. So we kind of like fighting for this resource, what might kind of break our tests in the end. They might get flaky and behave unexpectedly, things like this. And the last bad thing in this kind of like setup is that, well, imagine a situation I want to work on the train, maybe going back from work or going to work. And just when I work on something, I'd like to also test it to have this kind of immediate feedback that my implementation is working or not. But yeah, my internet connection might simply not work. And then if it doesn't work, I can't really work because I can connect to our infrastructure, and it just like kind of hurts my productivity. So our very simple and obvious solution for this, I guess, is Docker. And I'm sure like most of you heard about Docker, at least in the context of Swift on the backend of Swift server side. Docker simply leverages the concept of containers, and yeah, containers can be treated as extremely lightweight virtual machines. So we can run Linux, and we can run also our backend services on them. And here is our environment, like extremely simple. I kind of like embrace, I guess, a microservices architecture. So we have a service called Message SRV, and this service is responsible for communication with our clients, for dealing with WebSocket and our custom messaging protocol. And we have the second service called Store SRV, and this service is simply responsible for persistency. And in our case, this Store SRV is simply like a detail of a server. It doesn't really affect the client in any meaningful way because it might be replaced. It might be some other kind of storage. Maybe from one day we use SQL database, someone else will replace it with NoSQL base. It doesn't really affect us. So what we can do, we can simply mock this service. And by mocking, I mean do the same thing we do on the client. So just simply like mock, put another service with the endpoints that the message SRV expects, and that's it. There's one difference between this kind of mocking and mocking something in our client. Because those services are simply in Docker, and Docker is running in a separate process, we cannot just access memory directly. So here we need to find a way to kind of communicate with this mocked service. And the simple way we usually use is just a very basic HTTP endpoint. So, we expose some methods to reset the state of this mock, maybe to enqueue some messages in this case, maybe, just inspect the messages out there. And then we can use this from our integration tests. The same technique we can use for the proxy SRV. So instead of like installing the proxy on our host machine, we can leverage the fact that Docker is very kind of predictable and stable and can fix the version and make the installation for the developers very easy. So we can put it inside Docker. And again, we can put this small controller script with like a simple endpoint that allows us to tweak the settings of the proxy from the client code, from the tests. And there's one more bit we usually do, like kind of to a little bit, I would say, prettify our tests. So every time when you communicate with those mocked services, we need to send some usually very basic HTTP messages. And again, instead of creating those requests inside the code, which would make them very ugly, we just kind of like abstract them and put all the requests in a single layer, in the single set of classes we call environment controller. Last bit, to kind of make our user experience or developer experience a little bit better, is because Docker exposes a very nice command line tooling for like starting, stopping machines, building the machines. We can use it in our custom schemes for the integration test, like edit the pre and post actions for integration tests, and then every time when we call, run tests, the Xcode will simply start the Docker. And once the tests are finished, the Xcode will stop the Docker. So basically, the experience will be exactly the same for developers as they normally do have when they use unit tests. Here is very similar test we had before, except this time we use this mocked service. So at the very top, we simply like enqueue thousands of messages. Again, now we have this flexibility that we don't need to even send thousands of messages because we have this kind of a little bit smarter mock. So we can just send one request to say the mock, we just need to enqueue 1,000 messages like this. So we can do this. And then we connect to the server locally, which is running locally, and we expect all the messages to be delivered. And in this simple test, I simply just check only the count of the messages, but normally what we should do, we should also kind of verify the content of those messages, the order of the messages and things like this. Sure. But so far, we talked only about those scenarios that are kind of very optimistic. So, we always assume that the network was up and running and everything was OK. But we also need to be kind of ready with those situations when actually network is not really reliable. And now we need to set up some expectations. And I think a nice way of talking about this expectation is to defining the quality of service. And the quality of service is nothing else than like a contract between the sender and the recipient that defines the guarantee of delivery. And here we have like three simple categories that we can use. The first one, try to deliver maximum once. So it means if I send a message, if the message is delivered, it's great. If the message is dropped, it's also great according to the protocol. Deliver at least once means that the recipient can expect duplicates. So again, it might work. It's a bit harder to implement, but again, at least at this point, we don't have any data losses. And the last one, I guess the most heavy and tricky to implement is deliver exactly once. Because it's a demo and we are really focused on testing, we're going to focus on this one. So we want our client to get the message at least once. Here is a simple flow, just to visualize how the communication could look like. So first, there is a sender, and again, sender might be client or might be a server. This needs to be symmetric. So we have message A, and because the recipient is available, so it immediately responds with the ACK message. And there's the second message, again, the recipient is available, so it responds with ACK message, so the sender knows that it can send more messages. And now we have message C, C, and C, because the recipient is unavailable, so the sender waits a fixed period of time. Again, the recipient doesn't respond, so it sends the message again and again. And after a while, a recipient gets available, gets reachable, so the message is delivered and the flow is over. How we can test it? Well, relatively easy. So here is a very basic integration test that can kind of work around this the specification, these expectations. So here what we do, we simply again enqueue a fixed amount of messages on the server, then we call connect, and now we can use our proxy to simply toggle the connection. So we here kind of enable and disable connection every 3 seconds. So we're kind of making this kind of unreliable. And even we just toggle this connection over and over, we still expect the protocol to deliver all the messages. So our application still in the end should get all the messages from the server. And here's almost the same test, just a few little tweaks. So we first, again, enqueue a message, but then we immediately block the connection. And after we block the connection, we try to connect from the client. After a few seconds, we unblock the connection, and we expect the messages, the single message here, to be delivered to the client. And yeah, this test is, in my demo, failing, simply because, well, when we send the first WebSocket API request, the request obviously is failing because there is no connection to the server, and then I don't have any retry logic. So yeah, but at least now I know, so I can go back to my code and fix it and work with those tests. And again, by using this technique, we can write lots of tests, verifying some kind of concurrency behavior, some performance. But the last test I like to kind of show you is the one that checks deallocation. And I know it might look a bit weird, are you going to test the init or something like this? And I think it's not the worst idea in the end. So what we do here, I want to make sure that the client can kind of gently deallocate. I mean, you're working in a situation when we have lots of messages going through. So our library, our basically stack is very busy. There's lots of concurrent jobs going on, and we still want to make sure that if the client of the library simply kind of reset the last reference, it goes away smoothly. So again, instead of thinking about the scenario, what happens, we can just simply test it. So here, what we do, again, we enqueue messages, we connect, and after a few seconds, we kneel the last strong reference. So we expect the client to be basically kneeled, deallocated, and then everything should go away smoothly. We should also check probably the listeners to make sure that they no longer receive events and things like this. And also to give us even more confidence, because we're not constrained by the time, so those tests don't need to be that fast. We can put this test in a kind of like loop and run it over again hundreds of thousands of times to make sure it's actually working. Last bit about kind of like developer flow. So I guess from my perspective, my experience with those tests, I think they're kind of like nicely boost your productivity because, well, everything is just up and running very quickly on your local machine. But on the other hand, I think generally like setting up a test with this Docker dependency might be a bit tricky to set up on the CI. And last bit, like kind of like wrap up of this example. This local test environment in Docker, again, it can be easily shared between multiple platforms. So probably your colleagues working on Android kind of like can use the same thing and help you maintain it, as well as the tests. I believe they can be easily ported. You know, just looking by some examples, and you basically just write it in Java on Kotlin. And the last bit, we all know unit tests are great, especially to like facilitate refactoring, help us with refactoring. But I think that using unit tests, it really helps with refactoring at the kind of like class level, you know, some internal details, kind of clean the code and things like this. But usually when we develop like bigger systems, you know, we're just thinking about design or maybe maintain a system and want to just replace a bigger chunks of code, maybe a whole library or maybe a whole set of libraries and things like this, then unit tests are less helpful just because we need to usually adjust the code and also the tests because there are some contracts that are changing. And every time when we kind of like do both, I feel like we introduce some risks. So integration tests in that case wouldn't change. We could easily, as we saw, replace the WebSocket implementation. We can also put something on top of WebSocket which deals and gives us for free like delivery guarantee of delivery, things like this. And those tests stay the same, so we have this kind of like safety net in the end that whatever we do, we can run those tests at the end, and we know the messaging is working fine. Okay, that's all I have for you in this example. Now I'm gonna hand over to Kassem, who will talk about command line tools.
Yeah, next up, we're going to take a look at another context, that is command line tools. We'll look at how we can apply some different testing techniques to command line tools. And for this, we're going to be looking at an example. The example I'm going to present really is just to help illustrate some testing techniques, but the details of which doesn't really matter. You can apply them to any other command line tools. For this particular one, I'm going to look at Xcode. It's a tool we open sourced recently, and I'll be drawing some examples from it. So the first high-level overview, what does it do, just to help us understand how relevant the tests are for it. It lets you compare two Xcode projects. And your first thought is going to be, Cass, hold on, why do you need to do this? And there's a long explanation, which I'm really happy to go into in depth with you afterwards. Please find me. We started generating our projects because we have quite a lot of them. And if you've ever worked with a massive workspace, you'll probably have faced a lot of similar challenges that we have. So we started generating them. And of course, we wanted to do this incrementally and safely. We didn't want to just replace everything and say, will this work? Maybe, maybe not. But we wanted to add confidence. This seems to be the theme of today's presentations, by the way. So we wrote a tool to help us add confidence in another tool. So this is how life goes. But anyway, so we wrote a tool to help us compare two projects just to make sure that we can replace our original project with the generated project and make sure that it's the same. You might also think, hold on, aren't there standard diff tools? Why did you have to write your own? And another short explanation, if you've ever opened Xcode, it is very verbose. It is ugly. I do not envy anyone who has to work with this. Two reasons quickly. One, there are these nice references. Oh, by the way, this is a plist, a very old style plist, an open step, next step format. And every file in Xcode is listed there. It's a very verbose file. Every file has these unique references, these like UUIDs. And unfortunately, the original project and the generated project, they will probably have slightly different UUIDs. There's no guarantee they're going to be the same. Secondly, you've probably all seen you can arbitrarily order anything in Xcode, so you can drag and drop anywhere you like. But when we generate projects, we follow some conventions. So as such, the order isn't going to be the same. Unfortunately, using a standard diffing tool will not be very useful for us. So we wrote xcdiff to help us here. It just gives us some semantic diff of two projects. Like, do they have the same sources? Do they have the same resources? Do they have the same targets? Yada, yada. And if there's anything different, it will highlight it. It will say, hey, you have a missing header. That means we probably didn't configure our generator correctly. And of course, if there's any mismatch, even in the same files, like headers could have different attributes, it will flag the different attributes. All right, so that's kind of what Xcode does. I won't go into depth as to how it's structured, but rather just to highlight, it has some internal components, the ones in blue, and also some external libraries. The one we use is called Xcode Proj. Side note, I highly recommend you try it out or check it out if you're interested in anything related to Xcode project generation or automation. But yeah, so we use a third-party library as well. So the first test we'll be looking at in the context of this particular example is how a unit test for one of our components. It's called the header comparator. I hope the name explains what it does, but all it does is really it takes two Xcode projects and compares the headers for it. And this, we have different components that take care of different things. Anyway, this is what a unit test for it looks like. It's a typical unit test. You have some input, you perform some action, and you validate some output. In this particular case, we create two project descriptions purely in memory. Nothing's going to disk at this point. So we have a first project, a second project. We have some headers configured in them, and then we run our comparator. This is our subject in this example is the headers comparator. And then we validate there are no differences. They're the same headers in this example. Of course, we can vary the test a little bit, maybe have slightly different headers, and we validate the results match accordingly. So it'll say, hey, a1.h is in the first one, and a2.h is in the second one, and you don't have them matching. And then the third variant for this particular example is perhaps header with a different attribute. As you may know, Xcode has for headers, you can have three possible visibilities: public headers, private headers, and project headers. And in this particular test, we're testing that one project has a public header, another one has a project header, and that this mismatch is highlighted for us. And this particular test passes, and that's fantastic. However, when we first ran this, we implemented this feature, we started running the tool on a real project, and we were a little bit surprised. We ran it, and we saw this thing, nil. What is nil? This is not quite right. We didn't remember seeing any nils anywhere. So we opened up the project, and sure enough, it's project. And this was very confusing. We started digging into this, and it turns out, actually, it's an implementation detail of Xcode. It doesn't put any attributes for project headers. It simply omits them. It does for public and private headers, but not for project headers. Of course, now we know this. We had to go back and change our implementation. So this is an example of where our tests were passing just because based on our assumptions. So we can make the tests pass, but unfortunately, our assumptions were wrong. The tests were still passing, but we got unexpected results. What we can do to help us kind of add more confidence and catch these cases is to perhaps test with a few more components and read some real Xcode projects. In this particular case, we ended up creating some fixtures. These are like test projects that live on disk that we can read and that have these particular differences so that we can test some real scenarios. And that's what we did. So we ended up writing an integration test that, for example, loads two projects. It's very similar to what we had. The only difference now is we're reading some real projects from disk and then running our test. This particular example would have failed because, as we discovered, there is no such thing as a project header attribute. Now we know this, we've changed that, and when we replace it with nil, it's all good. Having discovered this, actually, we've revisited the implementation of our comparator to give us some more information. Nil is fine, but if anyone else uses the tool, they will be also confused. What does this nil thing mean? So we changed our implementation based on these discoveries to annotate this particular scenario and say nil, oh, by the way, that means project. So hopefully it will help out. And once we discovered this, we went back and updated our unit tests to match accordingly. So that's an example of an integration test where helped us kind of build some more confidence in our whole system. We can, of course, expand the integration tests to cover more and more components and maybe keep some others mocked. Why might we do this? And we have another feature that we wanted to test out. If you run Xcode just on its own without any option, the thing it will do is it will scan the current directory and it will try and pick out any two projects to do a diff. We just wanted to make it as fast as possible to get up and running with it. So we wanted to test this feature. So we kept all the existing components, the real ones, and we just mocked the file systems. So whenever it's asked, hey, what's in the current directory, we can actually tell it, hey, actually return these two projects. And this meant we could return the same project, and we can guarantee that we can get a successful result. In the command line world, exit code of 0 means a success. So because it's the same project, of course, we hope if we compare the same project against itself, it will be successful. If it isn't, then something's clearly wrong with our implementation. And we can write some more tests. This time, maybe we can examine the final output. And this is actually like you could potentially argue this is an end-to-end test, because in this case, we can get the final output that we get. And this will give us the most confidence to make sure that what we're printing out is exactly what we expect it to, using some real projects. This is fine if you have maybe a handful of tests, but I've just zoomed out a little bit and you can't even see the full output. So if you have a lot more of these tests, it'll become very unmanageable in your test files. A simple thing you can do is simply just cut that output, put it in a separate file, and that way now you have a much easier way to manage these expectations. So now you can change your test and simply read the output from a file. It's the same test. The only difference now is instead of inlining the output, we read it from a file. And this is really nice because if you ever want to update this file, you can run the command yourself and then just pipe the output to that file. So it makes it easy to update. We can run different tests, maybe change the projects. So this is the command input, for example, and change the expectation. And in this case, the exit code should change. For us, if we detect a difference, we have an exit code of 2. And then we can also add some more options, validate the output as well. And as you probably noticed, there's some commonality between all these tests. Unless I pointed out what was different, you might have not spotted that they are different tests. And the 3 things in common between all these things really are the input, like what are the options we're passing into our system, and then the expected exit code and the expected output. And we can group all these 3 pieces of information into a specification, and this means we can reason about our test in one place, because in the previous approach, it was fine, but unfortunately, half of the test is here. So you can look here, you see, oh, I see what you're trying to test, and then you have to look at that external file to see what you expect it to get out. And yeah, grouping this all together makes it a lot easier to reason about things. What you can do is modify your tests to perhaps parse these specification files, and then from there, you can tweak the test such that it will iterate through, like say, for example, scan this directory for specifications. It will iterate through them and perform the test one by one. And this means if we ever want to add a test, we don't have to modify our code. We just simply drop in a new specification file. This is great. There's some caveats, sadly, as with all things. At least the way we implemented it as one single test means if there's ever a failure, it means it will just fail like in that one test. So in Xcode, you won't get there won't be one per specification. There will just be one entry, which might be hard to debug. So we have to invest a bit more, perhaps in providing some better assertions, maybe to specify which specification failed. We have experimented with using some custom XC test classes to help us list them out. We weren't very successful with it. If you have had success with this in the past, please find us afterwards. We'd be very interested. So the nice thing about specifications, you can have them in any format you like. So why not Markdown? It looks really nice in your editor, even better on GitHub. And the nice thing about this is initially this started out as a testing mechanism for us, and now it's kind of like documentation. If you ever wondered what does this option do, you can have a look and see exactly what it will produce. It will produce an exit code of 0, and it will produce this particular output. And the nice thing is it's up-to-date documentation, because if we ever forget to update this, the test will fail. Nice. And as with all things again, you get some positives, and unfortunately there's some potential drawbacks. As you add more and more specifications, it's going to be hard to manage them and keep them up to date. And you don't want to be in a situation where you're afraid to update your implementation. Say we found a much better way to have some better indentation. Maybe we want to modify the format just so slightly, but it means we have to recreate our specifications. We might actually get discouraged and not do this change, but then that's in a really awkward position. Tests should help us add confidence in making changes and shouldn't make us fear making changes because we don't want to break the tests. If that's the case, then our tests aren't helping us. But luckily, this is a solvable problem. We can automate this. We ended up writing a small script. We tell it, please run these commands, like -l, for example, and then run the actual tool, capture its exit code, capture its output, and generate the specification. And this meant now we don't have to ever worry about recreating them ourselves. We can just run this test generator, and it will do it for us. In our case, our input to this tool, our script rather, was just a simple JSON file that enumerated all the different options we would like to test with some additional metadata just to help us reason about it. And this has been working really great for us, actually, especially during code review. And whenever anyone makes a change, we can always look at the specification files to see how this change impacts the final output. And it's also helped us spot things we never thought we would spot initially. This is actually a screenshot from a recent feature we added, a new comparator. And this is the output it produces, which looks fairly innocent. However, if we scrolled further down in the specification file, we would notice the same information was repeated, but by a different comparator. It's a totally innocent mistake. We had the same information being propagated by 2 separate comparators. And of course, if you unit test each of them in isolation, you would never spot this. But now we're running the whole system, you can see everything in one place. And we saw the duplication, and we ended up removing this duplicate information, and this was really useful. So that's it really for this example. I have just 2 main bits as summary points for this example. If you're using command line tools, do consider using fixtures. Test out some real world scenarios for your tools. And it's a lot easier in the command line world to do this than it is for applications. And then also, don't be afraid to leverage perhaps some helper scripts or anything just to help you manage your tests, just to streamline the process for you. And lastly, as a takeaway for this whole talk, thank you for your patience so far, is really testing our software can be challenging. It's like a challenge of its own. And you could get very creative and find ways to kind of go beyond the normal unit tests to add confidence in what we ship. And that's really the main benefit. It doesn't matter how you do it, what you call it, as long as it gives you value, adds confidence, and gives you a lot better product, why not? That's it. Thank you very much. Here are some references for things we either mentioned, highlighted, or referenced, used in this talk. And yeah, thank you very much. We might have a few minutes for questions if anyone's interested. But yeah, thank you. Oh, yes. 1 second, we'll get a microphone.
Hi.
Oh, sorry.
Oh, okay. So great talk. My question is around the first example. So what does testing locally on your machine look like? Does it take too long because it's booting up a bunch of Docker containers? How do you onboard new engineers? Do you ask them to install Docker? Do you teach them Docker? How does that work?
Oh yeah, it's a really good question. So I think in terms of installing first, so yeah, building basically building images and then containers, it takes a while the first time, but because we have our own repository locally, so again, pulling the images, most of them are already ready, so it's relatively quickly. Once you have your kind of local cached warm-up, then running the test is very simple. So that's kind of a bit surprise actually, because all we need to wait for is just setting up maybe, we're not gonna bring, small disclaimer, we never bring all the infrastructure. So again, we usually try to bring the services which are relevant to the mobile, and the rest is mocked. In that case, we just booting them. So booting usually takes no longer than 30 seconds. Then running tests, and that's it. And in terms of running those tests, they are very, very fast. Everything is local, so yeah.
Cool. There's another question here.
Thank you. Well, you actually answered partially because my first question was about where do you keep this Docker? So in the same repository as your project, right?
So Docker, so it depends, I guess. So we have some images which are used by the company already, and for example, we're just gonna use the real implementations and just pointing to real images. There are some things like the mocks, which again, this is our things we do normally. So we have the image files stored basically in the same repository, and that's it. And they're combined in the Docker compose YAML file. That's our kind of basic solution. Well, I guess if you want to reuse the mocks, again, you could have them in repo.
And how do you keep them up to date with production environment?
It's really a good question. So I don't think we have a super great solution for this. It's more we have some communication between the teams and saying this was rolled out, we have a new version, we should test against it.
For some of the newer services, as part of the CI pipeline, it builds a Docker image and uploads the latest image. As such, when we run the test, it pulls the latest one. And this is a mechanism that we started finding to help us out.
Hi. Thanks. That was a really, really great talk. I really enjoyed that. I just wanted to ask you, you mentioned CI challenges, and I wanted to ask quickly about what types of the tests you run on every pull request versus not. And with your Docker setup, does that require that you use on-prem CI, or do you have cloud CI that you leverage?
Ask me, okay.
Can help.
So, long story short, currently we do not use Docker tests which using Docker on the CI. for various reasons. But I guess what we have instead is every time when we affect a code or we change the code that actually should also be tested with the Docker, then we have some kind of like danger rule that prints out on the PR, and you need to just use the Docker. In terms of all the kinds of testing tasks that we're going to cover.
Yeah, so one thing which we didn't get a chance to cover in this particular talk is, even though we use Docker, that's kind of like the equivalent of our end-to-end, but there's actually many layers before that. One technique we followed, which we unfortunately didn't get a chance to present, you could implement an in-process TCP server to test some WebSocket behaviors. That was very helpful for us for testing some like propagation of error codes and like the error messages and stuff. And for those integration tests, they're capable of just running a vanilla XC test without any special environment. It is a bit challenging at the moment with Docker, but we're hoping there'll be a different story in the future. Yeah.
And what about like cloud CI providers, or do you have everything kind of deployed on-prem in-house?
At the moment, it's all on-prem. Yeah. Cool. Yeah, I think we have one more question. Time for one more question.
So about that slide that you had in the first example about a message service running locally, and you sort of have this endpoint that you talk to with HTTP. Correct me if I'm wrong, but you're basically adding an undocumented HTTP endpoint to a service that did not exist before, that would otherwise not have it?
Can we just bring this?
Yeah.
Sure. It's. I think I know what you mentioned.
Like, would this endpoint exist on production as well?
Oh, the proxy.
Yeah.
Oh, in this scenario, no. This is like artificial proxy just for us. Normally, yes, we normally have the proxy, and normally it would be also part of the environment, and we have this kind of test as well. But this particular proxy to simulate like weird network conditions is like our artificial mock.
Oh, okay, and then you switch this off in production when you're running it.
It's on production. The only thing on production
is the green box, pretty much. That's the original implementation. Everything else is just like mock, something we came up with.
All right. Yeah. Thank you all very much. I believe we now have a break. Thank you.